crafting embedded domain-specific language, or EDSL, in C++ using template metaprogramming, operator overloading, Lambda, and macro. So in here, we're going to talk a little bit about how if we want to make some kind of implementation with EDSL in C++ without relying on an external compiler or external parser, analyzer, or something like that, we are going to use exactly only C++ compilers in order to build our own EDSL language. So just first, quick introductions. So my name is Gilang. You can call me Gilang. I come from Indonesia. So, but currently I'm living in Finland because I'm studying here. I'm studying in Finland, security and cloud computing. Previously, I was working at Accenture as a consultant, and then I decided to move out of the consulting business into software engineering. Then I worked for Samsung for 3 years, where I encountered several projects in C++, and then which actually comes with this idea and experimentation with C++ metaprogramming and framework development or such like that. So basically, those are like there's a little background why I got indulged into making an EDSL or maybe like a framework in C++. So just have a short little storytelling about why I got involved in this. So back then, it was like I was only like 3 months working in Samsung. I was just starting working at Samsung. So I was at the time working for a Java project at the time, and then I was really tired and in the afternoon, and I went into a break room, and they call it actually ideation room, but actually it's a place for us that sometimes that we can use for sleeping. So I was sleeping there, and then suddenly I just woke up, and then I woke up quite late after the break time, and then I saw like my boss with some other team are actually talking, and I just woke up and then feeling lost. And then suddenly my boss just talked to me, I saw you, Gilang, and hey Gilang, why don't you go to India to learn the Tizen things? And then I just, what are you talking about? Going to India just out of nowhere without telling me before? And then, yeah, we're going to India. When? It's like next month. Oh, I mean, it's really fast. I mean, what are you expecting from me? And then, yeah, we're going to develop an application in Tizen platform. We are going to make because they want to release Tizen device in Indonesia. So Samsung Indonesia has to make like applications and like like making applications and also like preloaded apps and so on. So we have to make an application in Tizen, and like the entire team in Samsung at the time doesn't have any experience with Tizen before. So basically that's a new thing, including me. So therefore, okay, maybe I just let's go with the theme, and then I just read the Tizen SDK that what is actually Tizen is and what is actually how to develop Tizen application in Tizen. And apparently that the API that they use is a flat C API. So basically, they only promotes that using a procedural language, which is C, to develop the apps. And then I found out, oh my God, that will be a very, very tiring thing. I mean, to code for a user application using C in a very short time amount. Of course, it will be like very hard to do. And then I proposed them, I don't want to do that. I want to do something with something different. So I'm going for C++. Let's just try to do it C++. And then, fortunately, that Tizen SDK provides the necessary toolchain for compiling the C++ code. So then, try to experiment things, and then finally we come up with the idea of making a framework and making stuff that actually to help other team members who never really experienced with programming in natives before, where most of them like coming from Android or Java, to actually code easier to make application in Tizen. And it kind of worked out, and actually one of it is actually the thing that I'm going to talk in here. So basically the idea is I want to make asynchronous code looks better in codes. So we are in the further progress in the talk, I will show you why actually I want to make something like this. So the idea is I want to make a like asynchronous operation using some kind of syntax that is actually similar with a try-catch block or something like that. Or maybe you have encountered in Java, there is a synchronous block in Java where if you put codes in it and it will run asynchronously with the main thread or such like that. And we actually want to mimic something like that in C++. And also, we want to make it so that's why that will be beneficial for the other programmers to implement this in their code. So that's why in this talk, I expect you that you will gain information about how to design EDSL using C++ language construct with only C++ compilers without additional compilers. So we are dealing entirely with C++ language only. And then I'm going to share you about the basic concept of EDSL processing and then some of the metaprogramming recipes that we can use for our EDSL languages. So, and then about the prerequisite skills, maybe some of you already ask about the prerequisite skills because what maybe you need to do before you can make like actual EDSL in C++. Well, basically, this topic is actually for everyone who are interested in building libraries and frameworks, and actually for everyone who wants to make a neat code. Because, you know, sometimes if you want to make a neat code, you have to have a design pattern and something that you have to make some kind of like arrangement in your codes. So it is actually for everyone who likes neat things in their codes. So, and at least that if you know the basic features of C++, like operator overloading, like how to design class, how to make like what's the differences between member functions, static member functions, at least you're good to go. And then also in here, do you need any knowledge about compiler construction? But basically it's not really, because I myself, I don't really have any experience with compilers before at the time when I was writing this. And the thing that when I was learning about compiler construction was only in my campus, like about 5 years ago when I was writing this. And at that time when I completed the class, I exactly don't know anything about compilers, even though I took the compiler classes. So basically there's nothing that you need to worry about the compiler things. I also going to share you some things that is related with the compiler things, but in a very short way, and it's very, quite explanatory. So, what is EDSL basically? Before we are going through to EDSL, we need to take a look. What is DSL actually? DSL, or domain-specific language, is a language that is designed specifically for a specific application domain or purposes. So for the example in here, I gave like HTML, logo, or SQL. HTML is a very specific language that you use for designing a web page or for generating web page. And then SQL is basically a programming language that is designed for making queries to a database. So DSL is very different with the GPL. GPL is a general purpose language, which is like a C++ or Java or other things, which is like you can practically make anything with GPL language. But with DSL, you can only make specific things with that. But even though that is limited, it is actually more expressive, and it can actually give more like a clear information behind those languages. So actually it will give a potential gain in productivity, because you will actually easily to understand what is the meaning of the code. Like when you are making a query in SQL, like you have to only like define a select the columns from the tables and such things. If you want to make something like that in a GPL language, you have to go through the for loop and everything, which is a very verbose and a very hard. But with SQL, it's actually very straightforward. So that is the thing about the DSL. And EDSL is basically a DSL which is built upon the existing programming language infrastructure. So basically it's like integrating a DSL inside a GPL programming language. So we put the DSL language inside a general purpose language. Maybe you have an experience with C#. There's a link queue in that. Basically this is similar like EDSL by itself, because it's like integrating the query language into a source code, into a general purpose language. So basically the reason why we use EDSL, or why we should think about it. Basically, there are a lot of examples about library using some kind of EDSL language itself. Like in here, I give an example of Boost.Spirit. That is like a library to create a parser using sets of grammar directly in C++ codes. They have a sets of like grammars, like a syntax that you can define your own grammar for a parser that you can directly write in your C++ codes. And then the Boost.Spirit will automatically generate the correct parser for you. So that's one of the examples. There are also like several other examples that you can actually found, even though that is actually quite rare. But those are the things that actually like EDSL can give a syntactic sugar for our custom API or libraries. Like if you want to make if you have building a library that is quite complex or some things, you sometimes want to make it simplified so that the reader of the codes that going to use it will have a clear understanding about what is actually the meaning about the language itself. But back again, EDSL is basically not for everything, because designing EDSL basically is quite difficult. If you want to design a very complex language or a very complex operation with EDSL, basically it's quite hard. So you need to consider about the good design first. There are actually several other ways before you can considering about using EDSL in your library. So like you can use like a fluent API design or other part or other things like. There are a lot of other kind of patterns and styles that you can actually utilize other than EDSL. But if you are still going through with EDSL, there are several EDSL types that we can build with C++. I can like divide two types of EDSL that we can build. The first one is the static or compile time EDSL, which is basically it covers a boilerplate declaration. If you have like a template declaration that is very long, you want to make it shortened, like a short version, like you have a template declaration with a metaprogramming and blah, blah, blah. There's a very long list of like a type declaration. So you want to cover it up so you make your code more readable. So basically, static and compile time, the EDSL will only work in the static manner, I mean in the compile time manner. Usually it's also like generating a metadata inside your code, and then you want to use the metadata later on in the program. Basically there's something like that. And I can consider that static and, or compile time EDSL is a bit easier to build compared to the runtime EDSL in here. The runtime EDSL basically covers boilerplate statements. Basically, you want to put the EDSL inside your code statements. Compared to the static or compile time EDSL, basically it is on the declaration part of your codes instead of in the body part. So like if you want to make an EDSL integrated in the body of your function, you have to go with the runtime EDSL. So it covers up the boilerplate statement and also function definitions, and basically it is a little bit harder to build. And basically the example that I'm going to show you the asynchronous operation that we are trying to build is basically the runtime EDSL itself, and of course it's going to a little bit harder. So let's just get going for the harder one for now. So this is the case. Actually, this is the background reason why I want to make the EDSL for Tizen. So Tizen used this flat C API, as I mentioned earlier. It is used an EFL library. It is actually similar with a GTK plus library that is built entirely on top of C. And all of the API and all of the infrastructure of the language is basically for a procedural language. It is designed for a procedural language, although that it has object orientation inside it. Okay, so basically this is the case of that why I'm going to make a EDSL with a C++. So back again, Tizen use a flat C API, which is a EFL language. It is actually similar with GTK, but it is not as popular as GTK, but Tizen decided to use it. And we have to use everything procedurally. And in here, we have, if we want to make like a UI application or user application, especially Tizen, we are focusing on like for doing with mobile devices app. And in here, there are a lot of parts of the codes that will require an asynchronous operation. Like if you want to load a load of data from the internet, and if you want to have a long-running application in the background, you don't want to lose the responsiveness of your UI. So therefore, you have to put those actions in the background thread. But in EFL, the process to make a background thread is something like this. This is the function of in EFL API to call for a new thread. So ecore thread run, you have to pass a function pointers in there. There are 3 different function pointers. So one for the function asynchronous function, and the second one is for the functions that will be executed after the asynchronous code is completed. And then the other one is when the asynchronous operation is cancelled. And then Also, the last part is the pointer to void, which is when you pass the context or the user data, so it can be passed through to the callback functions. And we can see here, yeah, as we all know that C programming language basically doesn't have a type safety like that. And this is the thing that I think that we need to avoid, because those type safety actually creates a lot of trouble, especially when you have to deal with a very large code base and everything. And especially in the case when the people doesn't really understand, the programmers doesn't really understand how to design a safe code with C. So therefore, we are going to cover up this with our EDSL. So this is the basic design of EDSL, how we begin by designing EDSL. So creating EDSL can be thought or can be imagined that creating a new syntax in a programming language, in an existing programming language. The syntax can be for any purpose that doesn't really provide it in the original programming language, and we can feel free to adapt from anywhere, any part of the or other programming language, or you want to invent, or you want to get from C#, or you want to adopt from Java or everything. You feel like you want to integrate that in your library, so it's okay. Actually, it's feel free to us to adapt for something like that. And although it is not necessary, it is actually good to follow the original styles of the programming language, so you can make like the smooth transition between the original source code or the regular source code into our EDSL language. So therefore, it will not create some kind of confusion in the reader, in the programmer who reads the code, and will look more straightforward instead of like creating a difficult language to understand, especially like you introduce something new and then it's not quite frequent that people actually sees the code like that. So if you design that it's very fluently that can be integrated into the code, so it will look more natural. So in here, we want to try to design our asynchronous block in C++ code. So this kind, we want to design something like this. So we have those block with tfc_async and tfc_async_complete. We can think of that as a kind of new syntax or new keywords. And those keywords will be followed by some kind of statement blocks, something like that. And then in there, we want to define a grammar for this EDSL, and we can loosely define the grammar as something like this. So tfc_async will be followed by statement blocks, and then will be followed again by tfc_async_complete, and followed by another statement blocks. So the first statement blocks will be executed in the thread, and then the second statement blocks will be executed after the thread is completed. And then, actually, you can see there why there is semicolon here. Maybe you guys wondering, and we're going to talk about it later, why we actually have to have those semicolons there. And how do we implement the design here? So we have this, and then basically, as we can know that you can actually introduce anything in your C++ code, and you can actually maybe considering to use macro for that. You can actually use macro to create those new like keywords for that. And then the other part, we are thinking about using maybe how if we use Lambda. And then the choice why we are using Lambda in here, I'm going to explain that a bit later about why we actually specifically needs to use Lambda for this case. And in here, maybe you are wondering, Lambda actually has a very different syntax in C++. Basically, Lambda has this syntax. It has a capture part, it has a parameter part, and it also has a statement part. But in here, we only need the statement part. And how do we do this? We can actually hide it behind the macro. So in here, we define our keyword, or like a new keyword, as a macro, and then we put one part of our Lambda inside those macro. And then in here, we have something that we are going to talk about. We need to put something in there to make our EDSL actually meaningful to the program, to the C++ compiler. So basically, this is the thing that maybe we need to a little bit understand about the compiler, how actually compiler works, and how we can actually exploit the feature of C++ compiler to actually implement our EDSL language. So basically, of course, because we are designing a programming language that integrates into other programming language, we need to know how it's actually compiler is processed. And then this is a simplified process of the compilers from the Dragon book, the books of every compiler makers maybe already read. So the first part is a lexical analyzer, which is will process our source code and make a tokenization from each of the part of the source code. And then after it creates the tokenization of the part of the source code, it will go into the syntax analyzer. It will analyze all the syntax parts from those tokens and then identify whether it is a keyword or it is an identifier or the things. And then it will create a representation that can be read by the next process as a parse tree. We call that a parse tree, and then that parse tree will be transferred into the semantic analyzer, which will analyze actually the meaning behind those program that you write. And then if it's, maybe sometimes the syntax is correct, but actually it doesn't have any meaning. And the semantic analyzer can raise an error whether it has no meaning or it doesn't have any correct meaning for that. And the semantic analyzer can stop the compilation process. But if all of those things are validated, and then it goes through the code generator in here. So the code generator will generate the codes in after all the source code that we created. And in here, because we are going to use the C++ compiler, this part of lexical analyzer and syntax analyzer basically we cannot really do anything about it. We have to rely on the existing infrastructure provided by like the compilers. Maybe you use GCC or Clang or something else. Basically, we have to rely on them because if you want to make changes in them, you have to rewrite the compiler by itself. And we don't want to do that in here. And so the thing that we can actually manipulate is actually in the semantic analyzer and code generator. So why we can make manipulation in here? Because C++ is actually have a feature that where we can manipulate the semantic meaning of like the operator, where we have an operator overloading, which means that we can manipulate the semantics of the operators based on our own implementations. So in here is the thing that we are going to manipulate to exploit in the C++. So this is the example of our parse tree. We can define our formal grammar as this. The first one is the asynchronous block, which is producing TFC async keyword, and then followed by a statement list, and then finally followed by a completion handler. The statement list is just a statement list, a bracket statement list, and then completion handler is TFC async complete keyword followed by a statement block. So we can basically define the tree like this. We have those asynchronous block and the root part, and then we have the keyword TFC_async, and then followed by statement block, and then followed by completion handler. So we need to actually create those parse tree to process our actual EDSL. We have to simulate those parse tree so that the compilers can generate a correct code for us. So how to implement that? I told you that we are going to use the operator overloading. So because I told you before that operator actually enables us, we can manipulate the semantic meaning of the operators, and we can actually exploit that to simulate how the parse tree is processing inside our codes. So in here we are going to use operator overloading to build those parse tree and process our EDSL language and generates a correct code for us. And also, in C++ itself, operation actually can be used in any expression context and not tied to like any assignments, because if it's tied to any assignments, then you have to have a left-hand part and also right-hand part. But in here, like a statement like this, object A plus object B, and then ended with a semicolon, it is a correct syntax in C++. So basically, you can do anything with those operator overloading. You don't have any limitation in that. You will pick whatever operators that you want to overload and just follow the things that you want to see, that you need to simulate or your parse tree when designing it. And to overload operators, you can basically pick either the case that you want. The first, you want to make it like as a static function, or you can also use as a member function. And then the other terminology that we're going to talk about is about terminal symbol. So terminal symbol is basically a part that can appear in a language, and it can be keyword or identifiers or literals or anything. And terminal symbol in a parse tree is represented by a leaf. So if you see those parse tree, every leaf is a terminal symbol. And the thing is that we need the terminal symbol in our EDSL, but we cannot reuse existing terminal symbol. So therefore, we need to create for something else. We cannot use the existing keyword from C++. We cannot use like if or loop or something like that, because therefore we need to find other way to make our terminal symbols. And in here, actually, we can create a new class, which is a part of identifiers. We can use that to represent our terminal symbol in our EDSL. So in here, we have our grammars here. Those two are the terminal symbols. And then there are also statement blocks in here, even though that it is actually not a terminal symbol, but actually we can treat that as a terminal symbol in our EDSL processing, just for in this sake. Because in the C++ compiler, it will not be treated as a terminal symbol. It will be treated as a separate part, like a capture flag, and also like the parameter and also the body of the lambda. It will be treated as a different part of the language. But in here, for our EDSL processing, we can only take over of those items. So why we are also using the lambda in here? Because in C++, we can actually make compound statements appear anywhere, but we cannot have any like context behind this compound statements by itself, except if it is defined by the grammar. Like if followed by a compound statement. Compound statement is like a opening brackets and then a statement list and then a closing brackets. You can actually make anything without any if, without any while, or without any try catch. You can actually make it happen anywhere. But it cannot tie to any kind of meaning. It will only declare a block, which will declare like a variable lifetime and so on. It doesn't have anything. I mean, you cannot manipulate those things. So therefore, we can use the modern C++ Lambda feature, which therefore they can actually provide a mechanism to introduce a compound statements and then execute it as a separate function. So it can become a callable object, and then you can get that object, and then you can use that to process in the EDSL language. So that's the reason why we are going with this compound statements. So just let's get going to the parse tree that we are going to build. So in here we have the root of the tree, which is the asynchronous block. And in here we have the first hand, which is a TFC async keyword. And then in here we want to implement the keyword we create a custom class to represent the keyword in the parse tree. We create a class called async builder, which will represent the TFC async keyword. And then it will be our terminal objects. And then the next part is the lambda statements, which will cover statement blocks part. And in here, it is actually a native C++ object, and then we can process it using the operator overloads, where we join those two parts of the objects with the operator bitwise AND in here. So in here, we see that we have this class declaration. We create the async builder class, and then we overload the operator bitwise AND. And then we accept the right-hand part of the operator to accept lambda expression. That's why in here that we use the template, so therefore it can accept any lambda, because lambda can be anything. You cannot define any, you cannot explicitly tell what the lambda type is, so therefore you need template in that. So then again, the compilers actually need to see this. Async builder, operator bitwise and followed by a lambda, and then ended by a semicolon. So how to make it a bit cleaner? I've told you before, we need to use the preprocessor. We can define that TFC async builder followed by a operator bitwise and followed by the opening part of the lambda expression. So this is what is going to look like in the programmers. So the programmer will only have to see this. They don't have to see like those boilerplate code, those obscure using the operator overloading. You can cover up using the preprocessor keyword, using define keyword. So therefore, they don't have to use that. And that's why we need the semicolon there, because it has to be treated as one statement actually in C++. If there's no semicolon, it will not be a valid statement in C++. So therefore, we need those to actually end the statements. And all of those operator processing, I mean like operator overloading and making like an expression to process our EDSL, basically will be treated as one valid statement. So therefore, all of the statements that happens inside that one line will have to be a valid C++ statements. So therefore, we need to follow all of the C++ rules for that. And then in here, if you, this is the place that you can implement basically what is actually going on after you write those code, what is actually have to be done by the asynchronous function. You can put all entire implementation in those parts because it will be processed by as a root of the parse tree. So therefore, you can put anything, like anything that you want. Like if you want to define something like this, you put that in here. Maybe you call a create thread or using a pthread or something like that, function like that, or use the EFL function that I showed you earlier. And then the next, we have this, back again this, and then we have this. So what is how to use this part, how to incorporate this part in our EDSL? Because it's actually another dangling part that we haven't taken over. So we can call this actually a non-terminal production. So every grammar that doesn't produce as a terminal will be considered as a non-terminal production. So basically, like in the previous grammars, that we see that the completion handler is a non-terminal production. So therefore, it's actually the main grammar, the root grammar is also a non-terminal production. And in here, to represent a non-terminal production, you have to process it earlier and then give like a temporary object to give it in the higher level of the tree. So therefore, we need to make a definition for a temporary objects, and we also need to take notes that the C++, the operator overloads only have two kinds, which is one binary operators, and the other one is for unary operators. You cannot overload ternary operators or multiple other operators in C++ because it is limited there. So therefore, you have to make sure that your parse tree can be transformed into a binary tree instead, because at there you can actually put those terminal objects and also temporary object into one single operator overload. So in here we have this part. We can build from the bottom part of the parse tree into the top one, because it is actually easier for us to identify which bottom part of the parse tree and then goes up again until the root of the parse tree. And then we have in here the statement, the completion handler part, and then we make something actually similar that is previously that I explained it earlier, and the TFC async part. And then in here we pick the operator multiply in here because we need also to take notes on the operator precedence, because it will actually define what is actually the parse tree is going to look like. And if we need to, for the lower part of the tree, you have to put the operator with the higher precedence because it needs to be processed at a very early stage before the root part of the parse tree. So therefore, in here we pick the operator multiply, which is a higher precedence than the operator bitwise AND. And then the next part, we need to take over also to join that with other part of the tree, which is a statement block, because I told you earlier, we only have a binary operator to be overloaded. So therefore, we need to use the Lambda expression for the asynchronous part and then join it together with the temporary object that produced by the completion handler. So therefore, we need to overload that as a static function in here, which the first part is actually the Lambda, the left-hand part, and the right-hand part of the operator is actually the temporary object. So therefore, the C++ will identify that it is Lambda and paired with the temporary object completion operand, and then also followed by the operator. In here, we pick the operator shift right. So, and because shift right is actually lower precedence than operator multiply, but it is actually still higher precedence than operator bitwise AND. So we can pick that one, so because it will be part in the middle. So this is the actual parse tree that we are going to look like. So we have the lower part of the tree is actually async complete handler production, so with operator multiply. and then goes up into the part where it's joined with the asynchronous part, asynchronous block part with the operator bitwise shift right, and then finally it will be joined in the top with the operator bitwise AND to produce the actual meaning of the asynchronous operation. So this is actually also like the differences between those parts in the codes. And the blue part is the, I don't know what is that, I think it's cyan part, is a terminal symbol object. And then the blue part is a C++ terminal object, which will produce a callable object. And then the orange part will be a temporary operand object. And those temporary operand objects will need to be used for carrying the information upwards. We need to carry the lambda upwards until the top of the parse tree. So therefore, we need to put the information about our lambda inside those temporary objects. And we can actually put anything in that, not only like, in here we go, the example of lambda, but you can also like have a pre-processing there, or you want to identify something in the bottom part of the lower part of the parse tree, and you can put those information into the temporary objects. And then you can carry up into the higher level of the tree and then join up together with other parts of the language. And in here, to bring up the lambda upside to upper level, we can use either using a stud function, or you can also using template. But in here, if you use stud function, there will be a lot of overhead. So we are sticking to using templates because basically lambda itself can be stored as a template. It will be, yeah, maybe there's a cost of copying the lambda from one part of the expression into other part of the expression, but it is still lower overhead rather than using a stud function. So this is the example of carrying the lambda within the temporary objects. So we can put all of those information into the definition of the temporary objects. So in here, the complete operand will store the complete lambda, and the async operand will join the complete lambda and also the asynchronous lambda part. So in here that you can put any information and carry them outward and upward until the root of the parse tree where you can process, because every information is already completed, and then you can process it in the root part of the tree. And finally, what is compiler needs to read? So the compiler needs to read that the async builder object, and then followed by ampersand and so on and so on. And with proper preprocessor, we can hide all those boilerplate expressions into this, so we can achieve this syntactic sugar. So we can see that we can make something like this visually pleasing to the programmers, even though, yeah, maybe there's also some limitation that I'm going to talk you at the later part of the talk. But in here, we can see that we can make some expression that is cleaner to the user of our library. So the next part is, if we need to validate our EDSL, like the meaning or the semantics of our EDSL. Sometimes we also want to put the rules in our EDSL. We want to make rules, you want to control how the programmer is going to use our EDSL language. So you have to like erase a error message, or like validating whether programmers have put the correct things in our language or not, and then also give a proper error message that so the programmers can actually identify which is the error and then fix the error. And in here, we can use template metaprogramming to analyze the code. And then you can also give using a static assert to fail the compilation. You can put the message inside the static compilations. And modern C++ provide the type traits headers, which consists of many things that we can use to do some basic metaprogramming. And so let's try to enhance our lambda by implementing rules in our in here. So suppose that we want to return something from the asynchronous part. So basically, if you like already receiving data from the internet after like a long time processing, and then you finally got the data, and you want the data to be passed back again to the main thread. You want to pass the data main thread, and then the main thread, the completion handler, will process the data and do whatever it needs, like to show up to the user and so on. So how if we want to use that? And in our lambda expression, basically, because it is lambda, it is a function, you can have a return keyword inside the lambda. So we are trying to use or exploit those lambda features to return our value from the asynchronous operation into the completion handler, which will be run in the main thread. So this is like the lambda rules that we are going to make. So the first one, the async handler, the upper part, the first part of the lambda may return a value, or it may not too. So it depends whether it can return or it cannot too. And the second one is the completion handler can be 0 or 1 parameter. It depends on whether the first lambda is returning a type or not. And then the third one, the type of the return part of the lambda, of the first lambda, has to be exactly the same of the parameter of the completion lambda. So basically, we want to make something like this. In here, we have those return statements, and then we have use of the part of lambda because lambda have a parameter declaration. We can utilize that to actually declare the types that we are going to receive from the asynchronous part. So in here, you capture the data from the asynchronous part in this part. So this one will return the some data, and this will be performed in the background thread, and this will be performed in the main thread. So how do we implement the validation rules? Unfortunately, sometimes the current C++ library doesn't really have a lot of varieties of template metaprogramming rules, but actually there are a lot of implementations that really available on the internet, and also that we can also adopt. There are also a lot of books that actually have a very good information on how to make a template metaprogramming for that. And in here, we have one. The first one is we want to detect whether a type has a call operator in here. We use a FINE template metaprogramming in here. So basically in here, if we want to detect whether a T has an operator call, so it will return true, which is correct. Or otherwise, it will accept anything, and it will return incorrect. And then we can detect by the bool value that whether it has a call operator or not. And then the next part is that we can make to detect a pointer to member function arguments and also the return type. So we want to understand about the parameter inside the lambda, and also the return type of the lambda. So we need those kind of rules. And then we can exploit that using the template metaprogramming. This is the base template for all types. So if you supply any types, it will accept. It will not raise any compile error for that. But therefore, we need to specialize if we accept the pointer to member function in here. So we specialize that, and then we give the numbers of arguments that it has. It gives the return type, and also it gives the list of the arguments, and then there we can access it with using index, because it will be defined as a tuple. And then we can have a specialization if the member function is const qualified. So we can also add this one. So our pointer to member function, if we also want to accept the const qualified pointer to member function, we have to specialize this one. But basically, the steps are the same. And then the final part is we want to detect the callable objects. In this case, is lambda, and whether it is a callable object or not. And then basically in here we define the callable object as if it has a call operator, and if it doesn't have a call operator, it just returns false. It just gives a callable false. And then if it has a call operator, if it has a call operator, it will return a callable true, and then it will inherit the member function. So there we can access everything that we need to know about those callable objects. And then how do we mix those rules into our rules for the EDSL? So we can make the Boolean variable validation rules. And in here, to simplify the calling of the metaprogramming rules, we can using statements. And in here, the introspect L is for the callable object for the lambda, and then introspect CL is for the complete lambda. And this is for the first rule, that you want to have a 0 or 1 parameter and also return void in the complete lambda. So basically in here that we can use the rules first that the arity must be 1 or 0. So because it has to be either 1 or 0, the parameter of the completion lambda. And also that it has to check whether the return type of the lambda is void. Because if it is returning something from the complete lambda, it will be an invalid EDSL for us. And then the other part is that we want to check whether the return type of the first lambda is the same with the parameter of the second lambda. So in here we have a static context per bool validation because it's quite a long rules. So the first we are going to check the return type whether the first lambda is returning void. So therefore the completion lambda will need to have no parameter. So it will have a arity 0. And then, or it can also, like, if it has a return type, so it has to be the same with the second part lambda parameter. And then we can then call the static assert validation in here and then gives the error message to the user. And where to put all of those, we can put that in the temporary objects. Because in here we will get access to the template variables. So therefore we can put the static assert in there. And then if our lambda is giving like the invalid, or the user is giving an invalid rules, it's not according to the rules, it will raise a compile error. It's something like this, the example. In here that we are returning some value, a long value, but the completion handler doesn't give anything. And in here, in the Clang, for the example, because Clang gives a quite clearer error message, especially for my case. So it gives that it doesn't have failed the requirements and so on. So it will give a clear error message to our users. And then it also point out in part of here, which part is actually missing in here, and then the line numbers and everything. So users can directly go through there and fix their mistakes. And also we can also give the clear what is actually going on wrong with their codes. So basically that's how we implement the rules with Lambda, with the EDSL. Basically you can practically do almost anything with that. You can just be creative for that. And so finally, what is the limitation of EDSL with operator overloading? So the first one is like increasing the compilation time. Yeah, of course, using the template metaprogramming and stuff. Basically, it increased the time for the compilers to compile our program. And especially most of our codes is actually in the header part of the codes because template cannot work in the source part. So you have to put everything in the header. So it usually have to be recompiled again, and therefore, it will increase the compilation time if you incorporate it in quite heavy. And then also that we need to follow the C++ syntax and rules and also its limitations. And moreover, it is very difficult actually to define an EDSL grammar and using operator overloading because of the limitation of operator overloading itself. We have a very limited set of operators, and then the operators is only have a binary or unary operators, and you have to follow those operators only. You currently cannot make any new operators for that, but maybe if the future C++ can do that, maybe we can manipulate with that too. But in here now, we have to stick with this. And then the final part is that macro cannot actually carry anything about the semantics or syntactic information in that. So therefore, macro is only to cover up everything to make our codes looks beautiful, rather than seeing those boilerplate expressions and stuff like that. But still, at least that it gives like a clear or better readable codes compared to not using the macro by itself. So finally, the wrap up in here, I've told you about the operator overloading to simulate a parse tree to process the parse tree of EDSL. And then in here that I show you about the modern C++ features that we can use in our EDSL. And in here, because we are using Lambda expression in our EDSL, so therefore C++ prior to C++ 11, you cannot do with that because there's no such thing as Lambda expressions in C++ 03. And then template metaprogramming for validation, we can use that. We can define any rules with template metaprogramming. And especially like when C++ 20 is coming, like they have a concept, you can actually use that kind of rules. You can make your own rules with concepts and such things. And it will actually create a lot of more use cases in using this kind. And then finally, like macros, yeah, you can make a macro code suite, but like you see in the earlier talks from Brian, and that actually macro is like the earliest part of a generic programming like that. But yeah, it's actually like it can only be used for now. You can make a code like looks cleaner rather than to use it for other purposes like carrying semantics and so on. So that's why. And the final things is that you don't have to be in C++ standard committee to actually create a new syntax for C++. Basically, you can create with this or you can simulate with this. There are a lot of actually possibilities that you can make with C++ like this. And also that actually is cool if you are actually a part of the standard committee. And also like, yeah, just be creative in our projects and basically a lot of things that we can do with C++ and then you don't have to worry. There are a lot of workarounds if you want to implement something. You just have to creative with our codes, just that. Okay, that's all for my talks. And so do you have any questions? Or maybe I'm just really quite obscure. Do you have any questions or maybe ideas? Inside the TFC async? Like nesting those two statements, like you put TFC async and then you put TFC async inside the TFC asyncs. Let me remember my implementation. I think it can, because basically, yeah, I think it can. I think we have ever used that. I cannot really recall the use case that we have ever used with this project, but I think there are some part of our codes that, let me check again. I think I'm not really sure whether it's able or not, but if it doesn't, you can actually call another function and then put the TFC async in that other function. But yeah, basically I just don't really exactly remember which kind of use case, because it's actually like we ended the project almost like 6 months ago, so that's the last time maybe I was using it. And most of the time we only use for one statements only for this case, because yeah. Sometimes there are also like a conflicting grammar rules that we need to take notes and we need to consider on, and maybe they create some issues if you are nesting those statements inside. But practically, if you design it well, maybe you can mix those statements inside of those other statements. But I'm not really checking. And in here, maybe I can give you some samples in here. So let's check. Basically, this is the implementation. Maybe I will share you. Later. So in here we have this is the complete part. So maybe the example that we have in here, we have with rules. In here, this is the metaprogram one that I wrote in the slides too. And in here we have the EDSL definition. This is the operand. This is the complete operand. This is the builder, the terminal objects, and the operator overloads, and also like in here. And finally, it comes to the define part. And here you can see how it is actually actions in the codes. And in here, in this sample, actually, I'm going to show up that every part of the operator is actually showing up, giving up the output. So therefore, you can see how it's actually running in the background. So maybe we just go to the terminal and then open the terminal. Okay, and then I already compiled some of them. I think it's number 3. So this is with rules. That is the example. And here, so in here, we can see in the codes, the first part is before entering the block. It is hello. And then, again, In here, we go to TFC async. The first, it will process the complete with Lambda, which is this one. Will process with the complete builder. And then the next part is combining the complete operand and async Lambda to become an async operand. And then finally, go to the root type of the tree, which will cover async with operands. But in here, because we do nothing, we didn't call the Lambda itself, it doesn't show up the actual what the Lambda is running. And if you want to see the actual, I also have a sample in here that we have separated. I have a working example which calls Windows threading. So in here, we use some kind of create thread in here. There's an implementation. I'm not going through with that, but basically this is the implementation, final implementation of the Lambda. And then we have this one. This is the declaration of our Lambda language, and this is sample one. So in here we have several asynchronous operations. The first one is printing and then sleep for 2 seconds. And then another one is printing and sleep in 1 second. And then the other one is making a counter. And then in the completion, it gives the count of the loop. It is counting a random number. So in here, let's just check it out. I also have already compiled in here, just to save time. In here. So in here that we can see that the thread is running in the background, something like that, and then the thread that's running only for 2 seconds is sleeping longer than the one is running for sleeping for 1 second. And here there's a counter and so on, and then it can be processed in the completion handler where it can accept the value of the random number and such that. So basically this is our example of the running version of the Lambda, even though that it is not actually something like this, because the actual, yeah, please.
In this implementation, did you consider using the comma operator so that you could have something like Lambda chain to Lambda chain to Lambda?
Yes, actually, yeah. The question is like, is in this case that we can use like a comma operators, and then so therefore that we can change the Lambda and Lambda, or maybe you want to chain other objects and other objects and so on. Basically, we can use that, but we know that comma operator is actually in the very low part of the precedence, basically. So therefore, if we want to process it, you maybe have to put it inside a bracket, inside a parentheses, yeah, I'm sorry. Inside the parentheses, so therefore it will be processed earlier, and then you can get that, and the final end you get the temporary objects, and then you then going to the higher part of the expressions. But basically it is possible to that. But the thing is that you need to take on the parse tree to be processed in the correct way. So therefore maybe you have to mix with those parentheses and so on. But basically it is of course possible. So this is also like the sample code. Is there any other questions? Or maybe I'm wanting to show if I make some mistakes in here. Like in here that we are counting a integer, and maybe I'm accepting double. Also that, yeah, maybe returning integer and accepting in double, basically, of course, it is possible. Assigning integer to double is actually possible. But in metaprogramming, it is actually not equal, because it will see exactly the same, because I use the expression of stud is same phi, which is it will check whether the type A and type B is the same. So therefore, because the first type is integer and the second type is double, so therefore it will return false. So how if we make something like this and then try to build it? In here, then we show that there is an error in here. So there's an error, static assert required in different, something like that. So basically we can do the validation, and you can do with any cases that you may like. Maybe you want to implement like a query language inside the C++, or you want to make some kind of mathematical operations, matrix, and so on. There are also like I think I saw implementation of EDSL for defining a matrix. I forgot the name of the library, but there are something like that too. And also, a lot of things actually we can actually make use of it. So it is actually, the possibility is quite endless. So you just have to be creative in here. So is there any other questions that maybe, please?
Just one quick question. Would it be possible to use expression templates for HYPOTHETICAL?
Okay, expression templates, because the question is whether we can use expression templates for this case. And currently, because we haven't really checked, but I think it is possible using expression template for that. Because in here, like if you want to define something like a template with expression and something like that, you can incorporate that. Of course, you can incorporate that in your EDSL. But in this case, and also like I don't really have an experience of using those more modern features because it's actually quite newer. And in here, we are using the older version of modern C++. Basically, I was writing this on top of the C++ 11 and 14, so we haven't really checked about whether we can actually manipulate that. But actually, it's actually worth to try if you want to incorporate, like, to put expression template inside, or like making the EDSL language like this. But of course, it is possible. Yeah, okay, any other things? Okay. If not, maybe I'm the final, on the final part, I just want to say thank you for this people, for the Tizen team. I really say thank you to our team, especially Kevin Winata is one of my previous partner in Samsung. He helped me a lot with the library. Also thanks to Pratnya, Juan, and also Alvin, and also the rest of Tizen team. Special thanks to Risman and Januar. And also thanks to Pablo, Andrea, Kate, and Scott to give their feedbacks. And also thank you very much for the chairs and for the acceptance for the CppCon, because it is the first time for me to stand here. And I'm sorry if I have mistakes or something that may be quite obscure to you all. And hopefully that I can make something like that in the future and improve myself. So thank you very much for your attendance. I hope it gives you something to bring on home.